So hi all, I am Vijay Jethani. I am Cloud Solution Architect at Microsoft. So for today's session, which is on Dapr on Azure Hands-on Lab, we will start with what is the requirement of distributed application. So that will be the agenda to cover, like what exactly is the need of distributed application. And if you have attended previous session on microservices design and development, you almost know most of the things. And building upon that, we will look into the Dapr architecture, how it helps us with the distributed application. And then building upon that, we will cover the building blocks of Dapr, what exactly are those and how they are actually helping us build the microservices environment. And following that, we'll also look at the Dapr deployments. Now that is useful because we may be working in a hybrid environment. We'll be working in a physical environment. We can work on the cloud as well. So the Dapr should cover all of those environments is what we will cover in Dapr deployments. Following that, we will actually implement the Dapr hands-on lab for complete microservices end-to-end use case. And finally, I have to give you what exactly which solved for. That means if I am really using Dapr, what difference it make to the microservice deployments if I'm not using Dapr, and if I'm using Dapr, what are the advantages of that? So we will cover that as the agenda. Prerequisites, I think you already know. If you have to do hands-on lab, you need a Azure subscription at minimum. And if you are a DevOps person who wants to automate everything, then obviously Azure DevOps or GitHub is required. But I have not mandated purposely Azure DevOps or GitHub here. Reason is simple. You can try out a manual instructions as of now and then slowly build upon actually implementing this environment using Dapr. OK, and finally, the session takeaways are knowing the Dapr components and how do you actually implement Dapr for design and development. And then we will look into what exactly the building blocks or the Dapr integrations look like on the cloud or hybrid and all those things. And finally, obviously, whatever the hands-on lab which we are doing, we obviously will know how this is different from actual implementation of microservices without Dapr and what Dapr adds to the microservices world. OK, so this will be the brief of what are we going to cover in today's session. OK, so let's get started. So first of all, most of you know a distributed application architecture or a microservices world. So this is just rough sketch of what we are going through. Every application in itself is a building block, a task base, you can say, in which microservices are bound together and they live in its own boundary. OK, so these are different types of microservices which you have. Now to communicate with an outside world, that means whether it is your desktop or whether you have mobile devices or the laptops, whichever way you want to consume that. We have an API gateway, which takes care of security of these APIs. OK, so that is the reason we are trying to look at from the API perspective, because today microservices are actually working in a network environment. So previously, while you were working legacy, each of those processes or each of those applications, services were running in the memory of that particular machine. OK, so we were all the communications were happening internally. So they were internal processes. But now with this microservice world, everything is over APIs, which we expose. Hence, there is a need of network to network communication using API gateways. OK, and obviously, if we want to have a communication, we need a middleware which can pass on these messages to another service because they don't have knowledge about which other services are available. OK, so event bus helps us plumbing this for a complete end-to-end communication per se. So you have a UI, you have a API gateway, which is kind of a front end for you, a back end for your front end. OK, so this is what our actual services are running. And finally, we do the communications using event bus. So pretty much what we covered in our microservice design and development. OK, now having gone through this particular implementation, the challenges which we face in any particular customer environment is around how do we actually discover them without even having a plumbing, because We know if we are doing this plumbing either in your code or you are having any third party products, you want to have installed some agents to actually communicate to those particular services, whether one is to one or one is to many. So we should know what services are actually running. So that is the first challenge of distributed application. Second thing is, if I want to really communicate, and whether the communication is just for passing one particular request, which the next service will take care of, or it's a two-way communication. So I should know how I should communicate, or at least know, once I know the services, I should know that from an asynchronous per se, the response will be receiving at, I don't need to poll that service. That means there is a asynchronous communication. If I'm not polling that particular service, that means I'm requesting the response to come automatically by a function, task, whichever way you implement in your programming stack. Okay. And many a times what happen is, like, for that particular instance, a communication is okay. That means we are doing a communication one on one or one is to many. For that particular instance, if it is running in a container or stateless service, so that's okay. That is done. But how about if I'm working in a e-commerce industry and I'm actually going on to a particular website and purchasing something from that consumer application? For that, I need to know what I purchased last time. I need to know what the price was for that particular product. So for that, I need to have the inventory and all those things available in my profile. Similarly, if I'm handling the e-commerce website, I need to make sure whoever is the customer, they are able to complete the transactions, payment done in a seamless way. So this is what I'm saying about the contextual information across the transactions. So it can be per person across the consumers. So those are the challenges which you normally face, because you have to actually tie this code together while you communicate to respective services. So here they are given example of ordering service, the catalog service, the basket service. The basket is nothing but your items, right? Similarly, a catalog is nothing but the price and how the products, everything, whatever is hosted on that particular website. And ordering is my final order. After confirmation, I need to make sure that the inventory or that product itself is available. Then obviously I have to go through the payment, and finally the shipping has to be done. So these are the transactions you see quite often in the common e-commerce or commercial website. Okay, so that was about the contextual information. How do I handle that? How do I handle a resilient to failure? That means what happens is, many a times the service is not down, but due to the kind of the load you have on that website, you may have to retry that. But if I have to retry it manually for thousands of customers, that is really a difficult task. Similarly, even if I try to do this manually for a point of time for that particular node, it still has efforts involved in that. Okay, so obviously we have to take care of that. And with the giving example of this commerce industry itself, our demands may be fluctuating based on whether it is a holiday season or kind of when we are actually releasing any particular packages. So at that point, the demand will be increasing, and the rest of time it will be less, or maybe during the weekdays it will be less, and during weekends it will be more. And finally, how do we actually monitor them end to end is what is a requirement from a distributed application challenges. So so what we're trying to say here is, we did this deployment using microservice. It works well. We are not saying it is not working, but these are some of the challenges which we want to take or implement automatically for us, rather than we should focus on our application than actually working on plumbing with these particular services. So based upon that, these are some of the building blocks which distributed application looks at for building or communicating with service to service. Having a state management, that means transactions are stored. If I'm having one-to-many communications, how that should be taken care using publish subscribe. Bindings, I have to send emails. Similarly, if I have to run any scheduled jobs, those are also bindings. Actors are kind of a, I would say, a state management along with compute, which is kind of rather than using any particular databases or even I would say, a long running processes, I want to make sure that this actor uh, is nothing but from the as I said, computer and state store. So that will help me to complete that transaction and release that process for that particular transaction. That means instead of going to a database or having a compute plus state store, I'm wanted to implement that in a pure a transaction based service or as a process. So that is where the actor will come into picture. Observability is nothing but your monitoring that will be taken care, how which are the components which we want to monitor and all those things around the services, pods and all those things you can think of. And obviously secrets, because here everything is stateless. We need some way to communicate or some way to securely communicate within each of these services. Secrets is very important. And finally, the extensibility. Extensibility is more of like if I want to really do some any upgrade, or even if I want to extend this particular configuration, I want to connect to any particular third party cloud services. I need some way to do that. So that we can do with a extensibility or configuration management services. So these are the requirements end to end for this distributed application design. So while you do the microservices, if you're trying to do the plumbing around these of them in your code, that will be very bulky. So what if or how we can really resolve these challenges is what we are looking in the Dapr. So let's look at the Dapr architecture. Okay, so let's move to the Dapr. So first thing from an architecture per se is, as we are working with microservices, obviously it is over the APIs. So how do we use them? Whether it is HTTP or gRPC are the way we communicate. gRPC is the binary way of communicating, and HTTP is our traditional way of communicating, the way you communicate with your web services. Okay, so both are having advantages and disadvantages. So that as of now, we have these two particular API methodologies which we can communicate with your application. And remember, the main thing to note from a Dapper per se is the application should be untouched. That is the first thing. That means whatever plumbing we are trying to do here, we are not touching an application code at all. Dapper has to provide whatever we talked about from an application design requirements per se. All the building blocks which I have told you should happen by this sidecar terminology or sidecar architecture. So whatever I'm saying is, for each of your application, we will have a sidecar, and the intercommunication with those services will happen using these Dapper sidecars and building blocks. Okay. So whatever we have said is your primary service is untouched. You need not modify anything there. And it is the responsibility of Dapper to have provide you a communication pattern, or I would say end-to-end communication is taken care now by a Dapper control plane rather than you plumbing your code in your microservices environment. Okay, so this is what you will look at from a Dapper interface per se. So you have a sidecar running next to your application, and then there are building blocks for a specific distributed application requirements, like say state. If I want to manage the state, so it will be that particular state store will be required. If I want to do one is to many communication, then obviously the publish subscribe will be required. If I'm doing point to point communication, service invocation will be required. So those all things we will just learn one by one while I cover the building blocks. But meanwhile, you understand that what we are trying to do here is we don't want to disturb your application, and try to maintain the code as minimum as possible without touching your primary service. Okay, so this is how the Dapper interface will look like. Now, how it communicates, what we have been doing so far is we have been plumbing our code because we were communicating one to one or one to many using some kind of a middleware like event bus or those kind of things. So in that case, we need a bulky hard coding of the code in your application itself. which was actually doing the one-to-one or one-to-many communication for us. But with the help of Dapper, we have introduced a sidecar that is nothing but a container or process running next to your application, which will do the actual communication job for you. The actual request will still come from your front end, but the communication now will be done from your sidecar to sidecar rather than communicating directly to that service. And depending upon what you want to have out of it, whether you want to make this service stateful, whether you want to do a one-to-many communication, whether you want to do a configuration, whether you want to have a secret store, anything and everything possible for a distributed application, we are trying to do through a Dapper as a control plane. So components, you consider this as the control plane helping you out to communicate with the help of your sidecars, which sit next to your application. Okay. So if you see in a nutshell, what we are trying to say here is we are trying to bring whatever was a requirement from a distribution application stack per se is sits here. And then we are also making this independent of any code or framework. That means choose your own way of doing this particular microservice writing in your code of your own choice and framework. We are not even touching that. The only thing you are communicating now is using HTTP APIs or gRPC is what we require. And that anyway we were doing before using HTTP API. Now only we have also introduced gRPC because this is a binary format and used by most of the microservice communication. And we are not also stopping you from hosting this on any particular cloud platform. It can be either your own on-premise or hybrid or any particular cloud infrastructure. So with that, I think this is more towards an what the Dapper brings on table from a microservices design and implementation per se. I will just pause for a while so that you look at this particular slide and then we will move further on actual building blocks. So I will start from above. So you have a sidecar pattern with each of your app. Then this is the communication, how you do your communication across with Dapper building blocks and control plane along with your sidecar. And then what are you trying to expose is again, you are using APIs, but depending upon whether are using front end or you are using back end communication. So till the time the way we have talked about developer tools as well, there is a limitation of gRPC API. It cannot be consumed on your front end browsers. That is not still not supported. So for browsers, you still have to depend on HTTP API, but for backend communication, gRPC is what we are using in this particular example as well. Okay, so moving on. Now let's look at these building blocks and what they do. So first of all, let's look at service to service invocation. So as you see, this is more towards as is the service to service invocation. It's like communicating, right? So I want to actually communicate from one particular or point to point communication from one service to another service using endpoints, which are exposed using either HTTP or gRPC. Okay, so this is what we do a service to service communication. And uh, what we are trying to do here is instead of using our own code often or I would say instead of using the hard coding of communication from one service to another service, we have removed now this out of your application code to a separate container running outside of your service in a sidecar. Okay, so this is what we are doing with service to service. State management, again, if we want to really preserve something, like suppose if you are actually having added some of the items to your shopping basket. So until your session is alive, and even after that, if you come back with your using own profile, it should be still be saved. So that is possible with the help of state management. So we call that as a whatever caching terminology you may, or whatever the database you may be using, we call that as a state management for your session or profile. Then coming to publish and subscribe, this is obviously if you have worked on Azure Service Bus or Rabbit or any of those middleware which is used for publish subscribe communication, you already know that how we communicate using APIs. Even in our service oriented architectures also we were using exactly the same things. Only thing was that the services were running from a API per se, but the actually loose coupling was not done. That means each service was not having its own store or data store. But in microservice world, every service is an individual entity in itself. It does not depend on any other microservice. That is the reason we are able to upgrade them, scale them as and when we, or also I would say a better term will be to say them we use best of breed products and the platform to actually design and develop those services. So that is what we do in microservice. Okay. And then bindings obviously, as I said, it can be sending a simple email or even doing a schedule kind of job. So for that, first of all, I should know which are my inbounds and what is my input bindings and what should be my output bindings. That means if it is something coming as a trigger, it should be input. Something going out as a some state, or I would say historical data, that should go as output. So those are those kind of input and output bindings we want to have. And actors, this is a bit complex to understand, but think of this as a, instead of actually having a bounded something by a process, I'm actually creating a functional chain. Okay. Think of this as a functional change, which is available only for that particular, it is time bound. Say suppose I'm starting with my ordering. If I use this actor mechanism until I place that order successfully, this actor will help me maintain the state and also communicate to the other services. Now, simple example will be, say, suppose now I moved from a basket and I want to do the purchase or want to confirm my order. While I click on confirming the order, first thing it checks is whether that the product is available or not. So this is again done by a functional kind of methodology. Again, once that is there, I have to fetch the pricing if there's no change in pricing and all those things, and then confirm the order. Yes, all whatever quantities you want, you have asked for, those are available for the order, and the order is confirmed. Once the order is about to confirm, I have to ask for the payment. That is again the another kind of a service which takes care of the payment mechanism. And once payment is done, the shipping will come into picture, and a number of things happen after that, including in updating your inventory as well as having that order saved in your profile. Okay, so those all transactions are taken care by actor. Otherwise, I would have need a specific service only, or I would say a plumbing, the way we did in our previous distributed design for the microservices. Okay, distributed design driven. I have to write a plumbing code to actually do this kind of a job. That means I have to write a sync task for all of these things to be done. But with the help of Dapper, I get a really good building block known as actor, which can take care of this for doing these kind of a multi-service transactions with storing the state until the order is confirmed, or order can also be cancelled until that is done, but still I have saved the state for that particular transaction with the help of actor without even touching my actual application code. Okay, so that is what the actor will do for you. Observability is again the monitoring. So it can be your Azure monitor, it can be a monitoring from if you are using Kubernetes, you can use all the kind of those monitorings. So at the end of the day, what we want to know more on the monitoring is who is my inbound services, who are my outbound services. If I can get those, more than enough for me to, if because when it is just through three services, I can find that easily. But if it is going to hundreds of microservices, it will be difficult to know who are my input and who are the output. So for that, monitoring and observability. Also, second thing, when these microservices fail, even though we have a retry mechanism and all those things, still we need to monitor that whether that is really running or not, why these jobs are failing. So for that also we need a monitoring in place automatically. Secrets, as you already know, we are communicating in a world using service identities or some kind of identity mechanism. So secrets are very important. This provides us kind of a secret store. Now this again is a multi-cloud integration service. You can use your AWS, you can use your Google, you can use your Azure, you can even use the native Kubernetes store for putting the actual secrets in there. Okay, so we have the plumbing available for you for that as well. Configuration. Now for configuration, as you have seen the block called extensibility, whether I want to really update it to the new version or I want to do the integration with the third party, I should have some mechanism in place which can store this configuration, or it should notify me that yes, now this is the version I have to go for the upgrade. But for that, I have to really have the some kind of mechanism, key value kind of a mechanism which says me that this is what will be the next available particular version for this particular application. Similarly, if I am doing the kind of a key value the way we did for the application, if you have worked on app services, you are actually configuring some of the settings which you used to store in file in some of the key value pairs. Similar kind of key value pairs you can also put in this configuration box. Currently, for configuration as a service, we support three of the services. One is your app service configuration, another is Postgres, and third one is Redis. And this particular is still in alpha. You see this version is version 1 alpha. The others you can see they are version 1. That means they are ready for production. Okay, so the rest are ready for production. The last two, configuration and distributed log, are the alpha. Okay, now coming to the last part, which was a distributed lock. Okay, so distributed lock is nothing but if I want to really write, say suppose currently I'm writing to the catalog database for updating that particular inventory. Okay, so I'm updating one particular product. So at that time, no two services or no two particular can write together. At that point of time, I have to first of all lock that and then allow that service to write to that and then release the lock. But in a normal fashion, if you try to do that, there will be still some hits that the other services will not be able to access that. But this should happen automatically for me. That means once I complete my write, this should unlock itself and then other service should be able to write. So how do I handle this automatically is with the help of this distributed lock. That means I want to have resources right to that particular service, but in a very controlled and automated way, so that I don't have to monitor those particular, or don't have to write any plumbing code, like say suppose give it a 5 minutes of time for it to write, or maybe some few milliseconds or seconds, depending upon the service or kind of a job we are writing to. Okay, so I want to bring this out of that, and the Dapper provides us this building block using distributed lock, which helps us to do a one-to-one write in a controlled fashion, and then it releases the lock itself after that is done. So these are the building blocks from the Dapper, which we are actually going to implement in our microservices architecture. So again, I'm just wait or pause for a while until you look at each of them. Okay, so from service to service, still distributed lock. are the building blocks for this Dapper. Okay, so along with our sidecar, this is like we have a control plane which manages these all blocks for us, and then we communicate using our own app services, or we trigger using our app services using these Dapper sidecars is what you have from an architecture per se. So now let's look at the deployments. Now, using what we have learned so from a building block that you see at right hand side. Now, if you are setting up a development environment, you require a Docker desktop and Dapr CLI. So for that, obviously you have to download that binary, install that on your machine, and then have the Docker desktop as well. Once you do that, you will have these kind of 3 containers running, which are used for a specific purpose. Like actor placement is the which helps tracking the actor building block on respective nodes, right? Where it is placed and how do I how many actors are present and all those things. Okay, so it's kind of a mapping across those actor instances. And also I need to know what the kind of tracing for those particular uh, building blocks. Okay, so what exactly the service to service communication and the tracing is happening, so that we help kind of a monitoring you have implemented in your own local environment. Okay, and finally the Redis state store is nothing but to make this a microservice stateful. Okay, so you save and retrieve the data using publish subscribe using the state. So if you are implementing using Docker, I think you have this, and this is the basic services after installation of Docker you will see running without any application installed. Now, then once you install your application, and as you already have a Dapper CLI, you will run with this particular pattern and the sidecar will be created for you. Okay, which will run along with your app. And the rest of mechanism, as we talked, you have to communicate depending upon what is the need of that microservice. You select from these particular building blocks. And the hosting platform can be anything, right from your Windows, Mac, Linux machines. It can also be ARM, which is nothing but your mobile uh, related technology or the latest technology, which is for meant for mobile communication. Okay, so ARM based processors are very common in mobile technology. So this is your Dapper development environment. Okay, so this whatever you're doing currently is for Dapper development environment. So how this looks for your Kubernetes environment. So while you deploy this same, you will see there is a control plane components coming into picture, which will help us doing the communication from your app to building blocks. Okay, so components are moreover the same. The only thing is, as this is now a production environment which understand a fully microservice architecture, you have an actor placement. Okay, same to what you had here. Then you have a Dapper runtime injector, because previously what we used to have is we were creating this manually using this CLI, but in Kubernetes it should happen automatically. So while your application is actually created, the Dapper sidecar is injected in that particular next to your application as a in that particular pod as a next container. Also, while we do the communicating, while we communicate with each of the services, we need to do MTLS, right? Mutual transport layer security is what we want to do. So the creating of those certificate at runtime along with the identity is taken care by this Dapper Signatory service, which runs inside the pod along with your app. And again, the update update components is for your operator, which manages these control plane components. Okay, so this forms your control plane components which sit in the Dapper system. And then while you actually create your app, the Dapper sidecar will communicate with depending upon what particular building block or what particular service you want to consume. Okay, so this is how you will do the end-to-end plumbing in a Kubernetes architecture. Rest I think remains same, the base layer remains same, but the thing to note here is while this is very limited to Docker desktop, here you have a complete control plane running with these particular services or deployments in that you can clearly see in the Dapper system, that these are running as a control plane for you. And then while you implement your app, the sidecar will be injected by an injector. Similarly, whenever an actor will be required for any service, that will be done by your actor placement or consume using that particular control plane component. And then finally you talk to the depending upon your needs from the distributed components. Okay, so this is how is on the Kubernetes this will work. Coming to say suppose I don't have any Kubernetes, I don't want to have Kubernetes, I just have my VMs. How do I have a Dapper on that? To have the Dapper on it, first of all, I need an intelligent networking software, which here is console. So this is an open source software available for you as in a self-hosted module. You can install this on your cluster of services. This can run on any particular, maybe you can talk about the VMware or any particular clusters. This gets installed on your machine and it makes itself leader and followers so that it knows who is master and who is the follower. And then from there onwards, complete distributed networking along with the identity is taken care by this console, and you have a similar kind of components or control plane structure like actor placement and your certificate authority in each of those, because anyone can initiate that. Hence, there is a need of running that in a respective VMs so that this is taken MTLS or whatever communication we have that is secure. And whenever there's a need of any actor building block, that should also be taken care by this actor placement. So these are nothing but, as I said, there are a number of actors will be running at particular time. We just have to consume the service, just have to consume that actor and release that. It's as simple as that. Okay, so again, Windows, Linux, and ARM is the platform supported because we are now on the bare metal server and VM deployments. So again, I will pause for a while so that you look at this particular architecture or functional diagram. This is for your development. Similarly, for your Kubernetes deployments, remember this is for all clouds. Okay, this is Kubernetes at net as a Kubernetes as a platform. Okay, not as a Azure or Google. Everything, whatever who supports like AKS, EKS, or whichever you can see, this is for all Kubernetes deployment. So kindly make note of that. Finally, your own VM deployments you can use. So this is as is an open source. There is also a way to use the console cloud itself, where you get this as a platform as a service. So that is also available, but that is in a different shape and format. Like there is a console microservice itself, which you can consume directly and have a deployments that will be a ready to use product on which you can deploy your microservices. But this is do on your own kind of environments, which I'm showing in your diagram. Okay, so from the concept per se, we have so far covered the distributed architecture, what are its challenges, and then we covered the Dapr architecture, we covered the Dapr building blocks, and finally towards the Dapr deployment, how we do the deployments and whether it is a development, production, or the Kubernetes environment or your bare metal VMs. That is how we have seen for this particular concept. Dapr hands-on lab. This is an architecture functional diagram which we are going to implement. OK, so let me explain you step by step. So the front end it written in the Blazor WebAssembly. OK, so whatever the request is will come that will be from this particular front end. using HTTP, and then from there onwards, our request will be taken care with the help of API gateway. Okay, because we are working with a microservices world, so the request will be taken from an API gateway, and this particular API gateway, if it is one-on-one communication, and that will be taken care directly with the respective services. That is where you see the service invocation coming into picture. If it is a multi-service communication, then it will be handled with the help of web shopping aggregator. Okay, so that the coordination of or communication with the respective service is taken care in a controlled fashion. Okay, now difference between the above communication and the below communication is like only from whether you want to talk for one to one or one to many. Okay, so that is what we are, and also we have put the block so that what particular building block you are using from a Dapper person. Okay, so this is what we are saying from service invocation per se. Now, as this example is based upon the microservice deployment, now we have introduced a Dapper in this. Okay, so with the help of the Dapper, the building blocks you can clearly see: publish, subscribe. Then fourth one is on secrets. Sixth one is on state management. That means basket service uses these three building blocks, and communication is happening using Dapper sidecar. Okay. Similar to that is your catalog, which is having 3 and 4, publish, subscribe, and secrets. And one thing to note here on ordering is it has actors, which I said to you, like this will be important if we want to do a multiple service communication or we want to communicate on multiple tasks for which we want to store the state, is where actor comes into the picture. Okay, and the payment is again just using publish, subscribe method, and then this is nothing but the service bus based upon the RabbitMQ. Now, how this works, I think we have also written here clearly in the bulleted points. A front-end web app written Blazor, it sends a user request to API gateway, and then from there onwards, the API gateway extracts whether this is service to service, that is one to one, or it has to be taken care one to many using web shopping aggregator. And other request is what we are seeing from the this one to many, and then other requests are like what these particular individual service are doing here. Okay, say suppose basket service. So basket service manages the customer's shopping basket experience, and it has a Redis to store that caching or state for that particular instance. Then you have a catalog service, obviously, which manages the a shopping inventory, shopping complete catalog for the products which is holding. Identity service manage the authentication and identity. Ordering service manage all aspects of placing and managing orders, whether we are completing that order or we are canceling that order. Every that particular state is maintained with the help of actor, and the remaining services help them out. Like say bindings is how we are binded together. Similar is to case publish, subscribe, how we are communicating using the service bus. And obviously fourth is we need a secrets mechanism to communicate with each other service, right? So that is where each building block is given clearly and the flow is written in this. And this is also uh, like from your the microservice implementation which we did last time also is exactly the same. Okay, the only thing is here we have introduced the Dapper and we have simplified to extend. In the microservice implementation we were having a different API gateways for a mobile and different API gateways for the web because of this complexity, uh, and that is what we are trying to simplify here with the help of Dapper, that how we can simplify our architecture by using best of the breed products and with the Dapper as the building blocks. Now, coming to the step-by-step instructions, if you are setting up your own environment, I think you can go directly from a CLI and do the stuff of Dapper desktop and try to everything is given from you only need the CLI and the Docker desktop, and the rest all instructions are given here. And if you want to do from a Visual Studio as well, just have a clone of this particular repository, and then you can do and install using Visual Studio as well. Okay, so the instructions are clearly written in that particular each uh, link. Okay, so this I will be sharing with you once we complete that. But today what we are going to implement is using external Kubernetes cluster, which is nothing but Azure on Azure, which is AKS. Okay. You can also have this on a local Kubernetes using the Docker desktop. Okay, so that also you have the step-by-step instructions here while you go through this particular installation of Docker desktop on your own machine. Okay, so this is all there in a public repository, how you implement that. Today, we are going to implement on external AKS cluster. So that is what we are going to cover. Okay, so from step-by-step instructions per se, let me close out the other ones. So on Kubernetes cluster, what you need. So suppose I'm starting completely fresh. How do I install this on Kubernetes on AKS? Okay, so this is go and create first of all the resource group. There's a command line for that. Similarly, you have to create obviously the AKS cluster. Okay, so this is the command line. Just make sure you make these naming conventions unique so that you are able to create that cluster without any issues. And finally, you get that credentials in that particular CLI while you're creating this particular AKS cluster. Now, what is required apart from Kubernetes creating cluster is how do you install the ingress controller? So this link will help you to install the ingress controller, and you can directly use that link and install the ingress controller. Now, once you're done with step 1, 2, 3, and 4, that means you are now ready with your Kubernetes cluster running on Azure, that is AKS. And you can go and check if all the services are fine, basic system settings are fine, and depending upon the nodes, how many nodes you have configured, all nodes are running fine and all those things. Just check those particular settings. Once you are done with that, now the other part is how do I actually install the Dapr? Now for installing Dapr, there is a CLI depending upon different OS you are using. So suppose if I'm using Linux, I will just use this wget link from Dapr. Okay, copy it and install it on my Linux machine to get the Linux Dapr CLI. Similarly, someone wants to go on from the Windows. They have the PowerShell script, which will do exactly the same thing for me to install the Dapr CLI. And more on the Mac OS and the different. So ideally what I'm trying to say here is Dapr CLI will be installed after you set the cluster up. Okay, so once you set the cluster up, next part is to get the Dapr CLI installed. Once you have the Dapr CLI installed, or you can also follow this particular documentation, but that one which I've shown you, that is more prescriptive than going through this. Okay, because this again takes you to that link. So this I will share that link with you for installing on the different OS. Okay, so I have done with the Dapr CLI. Now what should I do next? I have to initialize this so that this Dapr installs the control plane component on my AKS cluster. So I will do that with Dapr initialize -k. With help of that, the Dapr control plane, whatever you have seen, the 4 placement servers and all will be installed in Dapr -system namespaces, and then you will see the deployments running for me as a control plane. That means now I am ready to actually create my application, and then this Dapper will inject the sidecar for me. Okay, so I would get the ingress controller IP. That's okay. And this is some host file entry you have to do so that you can access this particular URL from your web publicly. Okay, but the important part is for you to install this particular application, which is nothing but the eShop on Dapper, which we have seen here. Okay, so this is eShop and Dapper application which you're trying to install. Okay, so you already have a code while you clone that repository. Now, only thing you have to remember is go to the respective go to respective uh, folder. for installing that him chart, which are actually available in the CD. Then you have the deploy. Okay, him charts you have. So that is from there you will install that him chart, and it is also given here as well for Kubernetes. Okay, so in source code, from on the root of that you have a deploy, then create that is Kubernetes, and you go to that Helm folder, and from there onwards you have to just install the Helm chart, which has all the respective microservices which you want to install, and set the host name as eShop Dapper Intern. That is what you are trying to do. This, I think this step you can do afterwards as well. So there's no hard and fast, but then you can follow these instructions, and while you do so, the complete microservice will be installed with the Dapper. Okay, if you have done step by step, and then finally you can check your status. That means all the web services are running fine, and then how the look and feel of that microservices is. Okay, so from my end now, let's look at deploying that this step by step. Okay, so while this is given in an instruction format step by step, what I have done is I have created a automated DevOps actions, that is GitHub actions. Okay, so with help of GitHub actions, I'm deploying this on my Azure subscription. So let me bring that out. So this is my Azure subscription, and coming to my repository, I have a GitHub actions configured to create that cluster first. So my first step will be exactly same. I will create the cluster. Okay, so I'm creating the cluster with the help of. So I'm creating the cluster with the help of this GitHub actions file. Okay, the name of that cluster will be eShop resource group location, and the name of the cluster will be eShop Dapr HOL. And along with that, I will have a registry as well. While I'm not using registry currently, but if I have to modify this particular services, I will actually retain that locally, or if I do any changes, then I want to make sure that whatever I doing changes, that those are actually pushed into the container registry. Okay, so that reason I'm creating a registry as well. Okay, now steps with which I'm actually creating this is exactly same. Only thing is here, as I'm using GitHub Actions, I want to have a few of the prerequisite setups like kube login, which is required for my Kubernetes. Similarly, I also want to have my Azure subscription login, which I am giving the credentials here. And from here onwards, there's exactly the same step which we have taken manually. That means creating a resource group, then creating the container registry, and then doing the respective monitoring stuff. I'm adding a respective extensions, and then from here onwards, I'm actually creating the cluster. Okay, so this is a bit different than what you have seen in manual instructions is, because in that we are not using Azure AD integration. I'm going using GitHub Actions. I'm using Azure AD integration as well. So that at the end of the day, all my security related or role-based access is taken care using this particular uh, Azure AD. Okay, so I'm assigning myself permission of Kubernetes as well as to the service account with which I'm running the GitHub actions. Once I'm done with that, other part is exactly the same. The way you have installed the cluster, now you get the fetch the credentials from the cluster. So I'm actually connecting with the help of kube login and getting into the cluster or fetching the credentials for the cluster, and then installing the ingress controller on top of that. Okay, so you have used the web URL, but in case of my GitHub actions, I'm using a local modified file for that ingress controller so that I can use everything locally from my customized settings. Okay, so this is what I'm doing with the ingress controller. So ideally in your manual stuff and this GitHub actions, it's exactly the same thing. So let's try to first create the IKS cluster. So for that, I have to do the changes to this particular file. So let me do that right away. Create AKS cluster for Dapr hands-on labs. So I'm just putting the comment to trigger this GitHub action, which I've just shown you. So this will go and first of all fetch the secret of logging to the Azure subscription, and then it will do all the relevant stuff on this machine as well, like kube login installations and everything. What is the prerequisites required? Okay, so we have to wait until this finish and also navigate across step by step. So currently we are deploying AKS cluster. Meanwhile, I can also check on my Azure subscription that that resource group is getting created or not. So this is based on Dapper. Let me check on Dapper. That's still to come. Okay, has got created now. So name is E Sharp Dapper Hands-on Lab. So this should appear. Still to come. So sometimes it takes time to reflect, but I think we are okay until that reflects here. So currently it is deploying the AKS cluster. Okay, it has taken all the credentials and it did it the resource group creation and trying to create the cluster now. Okay, so it is here now. So we have Kubernetes and container registry. And based of what instructions we have given, what we are trying to do here is after creation of the cluster, which is just one made up of one node, I'm trying to make sure that I have a proper access, which I've given along with that command lines. And once I have access, I have to install the ingress controller. So that is what is the next step I'm trying to do with this hands-on lab on first part of the hands-on lab, which is creating the cluster. Also, apart from what we are trying to do here is I also installed the operations management. Similarly, there is AKS preview extension so that I get latest of what is available on AKS. Okay, and this is also a prerequisites for if you are trying to go with Azure AD integration or enable Azure AD role-based access on your Kubernetes. So that is the reason I'm having AKS preview. But while you are doing manually, you don't need this. You just have to follow this lab instructions. Okay, so whatever I have shown you here as a part of Kubernetes cluster, that is all you need to know or you need to do as a these 4 5 instructions, whatever 7 instructions which you have, just follow that properly. You should be able to run this particular hands-on lab. Okay, but while I'm doing with the role-based access control is to show you this different way of implementing this while you do in your actual production environment. Okay, so I'm just getting ready on the extensions is installed. Now it will try to get login and let's see. Okay, cluster is created now. It's trying to provide me all details about that, and then it will provide me access as well. Role assignments. I think you can see the role assignments. And then it go on and log in and to that cluster and created ingress controller for me. So while you do the ingress controller, it creates a lot of services along with the secrets. First of all, it creates a namespace, service accounts, and you can see all RABC authorization, cluster rule binding, everything it has done with that particular YAML file based upon the instructions we are provided in that. So our first part is over. That means the way in alignment to what you have to do manually. Our first part is done. That means creation of our cluster. Okay, along with the ingress controller. So that is four steps are done. Now let us try to initialize this with the Dapr. Okay, so similar to this, I have also written code for the Dapr initialization on this cluster. Okay, so let's go and look at that workflow. So this workflow is a straightforward. Again, I need a kube login to get login to that cluster and then authenticate that and pull the exactly the same instructions which I have shown you in the CLI, pull that and then finally initialize that so that control plane components are created on my AKS cluster. So this is straightforward. So let me try to do the changes to this particular files for this particular GitHub actions to run. Okay, so let me do that. So what I'm doing now is creating a Dapr control plane on my AKS cluster. Okay, so this will now go and deploy the Dapr control plane on my AKS. So procedure is exactly the same. Only thing I'm just trying to do this using GitHub Actions so that I do this directly on a Kubernetes cluster. You will also do the CLI installation on your machine, and that CLI installation will actually connect using your credentials to the cluster, whether that is a Docker desktop or if you are doing on a Kubernetes cluster. Accordingly, those control plane will be initialized. Okay, so it is now actually deploying that Docker control plane on my cluster. So I just want to see whether it has gone through everything and there is no error. That is what I want to see in its logs first. So you can check through the logs while this shows clean, but then you still have to see succeed and what exactly it ended with. Okay, so I had a Dapper namespace created and obviously it should have all the components running. Now let's compare and contrast whether we really see what we have seen in our diagram, architecture diagrams for the deployments. So I will go to the workloads and see those particular services running. Okay, so I have a Dapper system. I have a Dapper dashboard. Operator, as I said, it maintains the complete control plane components. Sanitary is where you will see the actual certificate authority and identity inform and sidecar injector is what you are using for your the injection in your application. Okay, so this is what you see in your deployments here. Okay, now on the services as well, you can go and check what are the services created. Ingress controller has that public IP assigned to you, and there will be the similar services available from Docker as well. Okay, so you just have to make sure all the workloads are green. Similar is the services along with the ingress. That is what is the just basic check you have to do. Okay, now our second part is also over. In contrast to what you did here with help of Dapr initialize K, and you did the Dapr CLI installation on your machine. Okay, now and you can get the IP address which I've shown you here in our box. I can directly copy here, but in your case, you can also run the command to get that IP or go to the Azure subscription to get that. Okay, and you will also make the host file entry for that or to connect to that. Okay, now let's do the last part of installing our applications. Exactly the same thing which I'm doing to the GitHub Actions. So let me go back to the code. Okay, so I have a containers deploy YAML file. The instructions are moreover same. I have to log on and create the kube login kind of environment and then authenticate with my Azure credentials as well. And finally, this provides the credentials as well as the kube login for me on this particular cluster. And then after that, I just have to go to that deploy KATS Helm part where my eShop application will be installed completely on AKS cluster. Okay, so let me do that. I have to do the changes to this file to get this triggered. Okay, so I'm creating containers for shop on Dapr. Okay, so this will set up my complete application. So let us view the GitHub actions, how that is going through the deployment. Okay, it's getting authenticated with the help of setting the context. It is getting me logged on. So now once it deploys the Helm chart, we will show that as a deployed. Okay, it shows deployed. Okay, so now what we have to check again here is we have to check our workloads. Okay, so as these are containers getting created, it will take some time to come up. Okay, so you have to give some time for them to come up. How you can check is the pods will show container creating in most of the cases. Okay, so and few of them it will be showing running where it has already come up. So while you keep on refreshing them, you can actually check the containers are getting created. Okay, so meanwhile, what we can do is until that comes up, I've already set up the parallel environment which shows this deployment. Okay, so what I can do is I can browse that directly using the same URL which for which we have done the DNS entry pointing to our ingress controller, right? So this is how the look and feel of that particular application will be. Okay, this is a UI set up using Blazor WebAssembly. Okay, and this is the cart provided by catalog service. Okay, and while I click on any of say take me and take any say let me take the one. I think I won't be able to add until I log in. So let me log in with any particular. So here I'm logged in. Now I should be able to pick up and add to the cart because it needs my authentication credentials. Okay, so now I should be able to pick up any. Okay, so suppose I want to order any hoodie. So you see that particular is available in my cart now. So this is coming from a catalog. This is your basket service. Okay. The moment you click on checkout, it will go to the ordering process, which will use a actor mechanism to first get this inventory of the product validated. Okay. So this is just the you have to put the enter and you have to click on place order. While you're placing order, inventory will be checked against that and you will see exactly following that order has been submitted. And this is where your actor, the function mechanism, which I was saying, the chain function task by task. So it got submitted. Now it is awaiting stock validation. Then it will show me the stock is validated. This is complete the function chaining, which I was talking about, the actor, which is doing as of now. And then finally, it will turn it to the validated state. Okay, so it turned out to be paid. So this is how you have implemented end-to-end mechanism. One more thing, how do I check the services are running up and fine? Before actually coming here, I can come and check for the services. All of my services are up and running. If anyone shows any particular problem, you can actually go and check what exactly it is not able to check for. Okay. And one more thing important for us was also to take a health check or have a Dapper kind of monitoring mechanism. So for that, we have a Dapper dashboard. So let me go to that as well. So I have just make a Dapper dashboard entry pointing to the ingress controller. Now, by default, you won't have an ingress controller entry. You can expose either directly that service using the public IP or you create an ingress resource. I will show you how I did that and make this service available in the ingress controller as well. OK, I made an ingress resource for this Dapper dashboard to be available. OK, so first of all of these services are running. Now let us check one by one. Say, let me go to the basket. It will give me some summary of that service, what the Dapper is injected, and give me a metadata about that. Annotations important for Dapper to actually do the injection of the sidecar. Okay, similarly, this is a YAML file which we have already provided with the help of chart. Whether I have any actor registered in this? No. And we can also check the running logs from these containers. Now this is a Dapper daemon. I'm just getting this live logs from that particular Dapper daemon. I can also check the log from my actual service, which is Basket API. So this is the log from my container, which is Basket API. So this was one particular service, right? So let us go back to the other service catalog. Similar kind of information. You have a metadata. You have a configuration, which is nothing but a YAML. Do have an actor and logs for Dapr daemon and the your actual catalog API. Okay, so this is the running log. Now let's come to the ordering service. Ordering service. Again, a similar kind of information. You get some summary, you get a metadata, labels and the annotations, and then configurations. You will see again the same whatever you have implemented using the Helm chart and whether actors are enabled. Yes, as of now, depending upon the load, it will provide the instructions 1, 2, 3, 4, n number of actors which will do that job, whatever I have shown you, right from when it goes from a basket service to order confirmation, it has to get it submitted, validated, and then accordingly stock await validating stock then validated, then finally going to the paid state. So all those are taken care with the help of that function chaining, which is nothing but actor here, which we are talking about. And here also, again, you can go and check the logs for either Dapper, and similarly, you can also check on order API. Okay, so that was all from what we have to see from this deployment. One more thing to note, there is one bug currently, which is with one particular image, due to which all service will start. Only two particular service will fail. One is the identity service and another is web shopping aggregate. This is because of the problem with one of the images it is pulling. Okay, so you can just change it manually in your code, or you can change it in a YAML here. I did it purpose. I have not changed it purposely in my code because otherwise you will not know what the problem is. But here I want to show you what change I am doing to bring this service up. Okay, so in, instead of latest, I'm trying to give service of 3 months back, which was on 31st March 2022, is the tag for that identity API. Once I change that, the identity service will come up, and by default, the web shopping aggregator is dependent on the identity service. So now this is running. So if I come back, my web shopping aggregator will also come up automatically. Now this will go into running state. Let me refresh this. Okay, so all my services are running now. Identity has started running after I changed the image, and finally my web shopping has also come live. Okay, so this was a small bug, you can say, until that image get fixed, but then we have the working environment ready to play around. Okay, so rest, I think you can go on and do the relevant stuff on your respective services, check for ingress. Okay, so just this is what the host we set while we deploy that. Okay, so coming back to our hands-on lab, what we did was we created this particular complete end-to-end environment, which was based on e-commerce use case, and we deployed this using GitHub Actions. Also, you can deploy this manually with the help of instructions which are provided. Okay, what we have to do is we have to check each and every whatever respective services this particular uh, individual microservice are using, so that you can actually check what and how they are actually working and how the code is actually done within this particular microservice along with the Dapper. Okay, so if I have to provide summary of what Dapper did to this particular implementation is what I have written here in the final summary. From an observability perspective, you see, I think we have seen the Dapper dashboard, and it provides us complete tracing along the logs of that services. Okay, similarly, without even writing any code, Dapper components are able to make us possible for that. And if you remember, as I said, like for whether that is a state publish or any particular building block, you can actually go and change the service to which we are integrating, like uh, whether it is Redis or whether it is any memory cache or any particular caching mechanism, any third party, you can actually just give the name of that, and that without even touching your code is what is meant by that, while you have a flexibility to change the infrastructure by without actually changing your code. Okay, on application service. Service invocation, the building block which we have seen is it is the our Dapper control plane providing MTLS capability, with help of which it provided the token which we have used at the while we do service to service communication with the help of service invocation. Okay, similarly, while we did the publish subscribe mechanism as well, we did a lot of plumbing while we did our final when we did a implementation of our previous microservice deployment, which was based on the containers. We did a lot of plumbing for a middleware, which was based on service bus and RabbitMQ. So that consists around 700 lines of code. With the help of Dapper, we just bring it trying to 35 back to 35 lines of code. So you can understand how this is actually helping developers to build or concentrate on their own service than actually working on the code itself. Okay, I'm on plumbing and integrating with the different. So you just have to change the respective files of that particular building block, and all is done with you without even touching your application code. And for binding, if you see that whatever the order confirmation, there has the email sent to the respective using send mail or whichever SMTP client you are using at that point of time. Okay, so you can actually bind that with your own configurations and actors. Obviously, this was the biggest one from an ordering service. We have seen how this got into the stock validation and validated the stock and finally confirm our order and finally converting to a order confirm once we have paid that charges for that purchase. Okay, so this is was end to end from an application, how we resolve the application challenges